Number 7, particularly. That's our focus.
We're worried about 7 o'clock.
No, we're not worried about 7 o'clock.
Not worried about that.
No. You guys, are you prepared?
We're always worried about 7 o'clock.
I already know what we're doing here.
But more particularly, we're worried about 12:22.
Okay. All right. Quincy has already decided that he is going to approach this problem factoring by grouping. So x cubed plus 3x squared minus 4x minus 12. Quincy says, forget the PRR stuff. This one's going to factor by grouping. Now, I'm going to factor it by grouping because that's always quicker and for me much more efficient. However, if you don't understand factoring by grouping, you don't notice you can factor by grouping, or you just flat out don't want to factor by grouping, can you do the PRR stuff?
Sure.
And the synthetic division and go that route? Absolutely. I'm not going to do that. I'm going to take an x squared out of the first 2. I'm going to take a -4 out of the last 2. And notice that when I do that, I get a common parentheses, which I am going to write down. Please do not square it. Don't write it twice. Just write it down. And then do a parentheses for everything else. So I wrote that one down. So I have x squared minus 4. Which factors, as the Chauncey says, as x plus 2, x minus 2. Right? So I'm going to go to my number line. And I'm going to put some dots on my number line. Where do you think those dots will be? At -3, -2, and +2. Please make sure you get all those dots on there in order. The right order on the number line. Should those be open dots, or should I color them in?
Open.
Those are open. Look at the symbol. Those are open. Okay, so now what do I do?
Choose a number.
I choose a number. Any number I want that isn't already up here.
-4.
-4. -4, somebody suggested. Okay. So -4 would give me -1. -2. And -6. So I am multiplying -1, -2, and -6. Does that end up greater than 0?
No.
No, a negative times a negative times a negative would not be bigger than 0, right? So this didn't work. I need bigger than 0, and this didn't come out bigger than 0. So, since that one doesn't work, this one will, this one won't, this one will. Remember, the only time you can't do that, every other thing, is if one of these had a square on it or something like that, okay? So what's my answer? I write it down. I've got -3 to -2, or 2 to infinity. Okay? All right, next. Now, the next one looks a little bit different. But don't be worried about it. Don't be scared of it. It's an inequality. And I'm going to tell you right away, there's 2 dots on this inequality. Do you want to take a guess where those 2 dots are? -1 and +3. Look at the problem, guys. -1, +3. Nothing tricky about it. Guess what I'm going to do now? Pick a number. Any number I want except the ones I have marked already. 1. The number 1 is right here. So that would give me 2 over -2. Is that the kind of answer that I was hoping to get? Yes. So this works. What does that mean about these two other ones?
They don't.
They don't. So the answer is -1 to 3. Wow, that didn't take long. That was easy.
Why can our quiz be like that?
That's real.
The other one was mind-boggling.
No. Okay. X squared minus 9, x squared minus 4. Hey, what do you think we'll do here? Factor everything, so this is an easy factoring. Nothing cancels. And since it's an inequality, I'm going to have a number line. And since there's 4 parentheses, I will have 4 dots. And those dots will be where?
-3.
-3, -2, 2 and 3. Notice the order I put them on my number line. They have to go in that order. Don't mix and match. Any of those dots colored in?
All.
Actually, this is a little bit of a trick. They're not all colored in. The only ones that are colored in are the 3s. Because what would happen if I actually let x be 2? If I actually let x be 2, what would happen here?
0.
I get a 0. And where is that parentheses? In the denominator. Can I have a 0 in the denominator?
Absolutely not.
Absolutely not. So, even though this makes it seem like the dots are all going to be colored in, you will never be able to color in your denominator dots. So if a dot's coming out of the denominator, like the 2s are coming out of the denominator, they'll never be colored in, because you can never be 0 in the bottom. You can't equal 0 in the bottom. Everybody got it? That's a tricky thing. You might forget, but try to remember. Okay, now what do I do? Pick any number I want. And you know what? I'm going to pick 0. 0 is like the easiest number. We've been picking other things. I'm going to pick 0. 0's right in here. So here I go. I'm putting in zeros. What do I get? 3 times -3 over -2 times 2. So I'm putting in zeros, and I end up with what? -9 over -4, which is positive. Is that what I wanted? So that section actually works. Which means, what about this one? Nope. How about this one? Yep. Other direction. What about this one? Nope. What about this one? Yep. So my answer is kind of this. My answer is going to be -infinity to -3, or -2 to 2, whoops, that's a bracket, or 3 to infinity. There's a lot going on. Take a look at that answer, make sure that makes sense to you. Remember to have your headphones on Monday.
Oh yeah. What are we doing? We jamming out?
I won't be here. So you're listening to me on video.
Oh yeah.
So you already do that, like,
When do you like?
Yeah, I pre-made one already.
When do you like take those in here?
Oh, was that the video you were working on earlier?
Do you make them when no one's in here, like by yourself?
Yeah.
Actually,
Is that what you were doing earlier?
That's what I was doing earlier, yeah.
is that not weird at all?
I don't know how to do that.
Ooh, Skype actually.
On Skype.
Okay,
Alright,
all right, so we good on this one? All right, now, take a look at the next one, number 10. What is different about number 10? There's a 4 instead of a 0.
Wow.
All right, kids, listen. You gotta have 0. I want you to look at all the inequalities that we've done. They've all had 0. If it doesn't have 0, then you make it have a 0. So I'm going to subtract that 4 over to the other side. You must have 0. So you're going to rearrange to get 0. Now, these are fractions, and they have to be subtracted. How do I subtract fractions?
Multiply.
I get a common denominator, so I need everybody paying attention. Some of you aren't too good with this. The common denominator is going to be x minus 3. So I am going to multiply the bottom and the top by x minus 3. Now, both of my fractions have an x minus 3 in the bottom. So instead of having 2 separate fractions, I can write 1. Okay? Now, what about the top? Well, I have my x plus 2. Now, what do I have over here, though? Minus 4x plus 12. Yep. You took negative 4 times x minus 3. So that would be negative 4x positive 12. Now we collect like terms. So I got my x minus 3 on the bottom, and what's going to be on the top?
Negative 3x plus 14.
Negative 3x plus 14. Now, does the problem look like number 8 or 9 that we just finished?
Yeah.
Yeah. So now I'm ready to draw my number line and put 2 dots on it. Now, one of the dots is at 3, right? Everybody can see that?
Mm-hmm.
This dot is harder to tell where it is, so I'm not going to guess. I'm going to figure out where that dot goes by doing 3x plus 14 equals 0. So I'll subtract 14 and divide. So where is that dot going to go? At positive 14 thirds? Which is 4 something, 4 point something. So I'm going to put 3 here, and I'm going to put 14 thirds here. One of my dots is at 3, one of my dots is at 14 thirds. Notice I didn't guess. I actually worked it out. So I knew that dot was going to be at 14 thirds. Now, pick any number you want. Let's not pick something crazy. How about something like 0? If I put 0 in, I get 14, 0's out here. I get 14 over negative 3.
Wait, when did...
I'm putting in 0. So I get 14 over negative 3. Is that less than 0?
Yeah.
Yes. So this works, does. Should I color in any of these dots? The numerator dot's going to get colored in. How about that 3? Never. Denominator dots. If you have a dot that comes out of the denominator, it will never be colored in. So my answer is everything from negative infinity to 3, or from 14 thirds to infinity. All right, we got one more. Okay, what do you think we're gonna do with this guy?
Same thing as well.
Same thing as last time. What is wrong with the problem? It does not have a 0. So we're gonna set it equal to 0. And that means subtracting the 2, you must have a 0 if you're doing an inequality. Zeros and number lines, that's part of the inequality process. Okay? So this is 2 over 1. What do I need to do? Exactly, I need a common denominator, so I'm going to multiply this by x minus 1, x minus 1. Okay, now do the denominators match? So I can write one fraction and the denominator will be x minus 1. Now what's going to go in the top? 3x plus 1, of course, that just stays the same. Now be careful here. Minus 2x plus 2. If you're not getting plus 2, you're not distributing right. It's negative 2 times x, negative 2 times negative 1. So now what have I got on the top? X plus 3, x minus 1. This is easier than the last one. I can tell where the dots are. Where do the dots go on my number line? Negative 3 and positive 1. Anything colored in?
No.
Look what you don't have. There's nowhere equal to, so nothing gets colored in if there's nowhere equal to. Right? Or equal to's are the only reason we color. Let's pick 0 again, it's my favorite. If I put 0 in, I get 3 over negative 1. Is that greater than 0? Is 3 over negative 1 positive? Nope, so that didn't work, which means this one will, and that one won't. So the answer is negative 3 to 1. Paul?
You said 0's on the right of the number line?
Oh my gosh!
Wow, Paul, good job.
All right, teacher meltdown. I thought that was a negative 1. Paul, you're exactly right. That's a positive 1. So we got to start over here. Not all over, but let me just draw my number line again. I know.
Are you blaming her?
Chemo brain. Okay, here we go. That's a positive 1. So I'm still going to try 0, but 0 is in here. And I'm still going to get negative 3 or 3 over negative 1 when I put in 0. And that is still not positive. So that doesn't work, which means these two will. So my answer is negative infinity to negative 3 or 1 to infinity. Thank you, Paul, very much.
Paul Wedge, the savior.
You're befuddled? It is a great word. I love it.
Flabbergasted.
And it sort of describes this group, a little befuddled. All right, here's what we're going to do. This is your exit ticket. This is your exit ticket. Yep, you don't get out of here until you do something for me.
What time do we actually get out?
Stop.
Wow.
Okay.
Yeah, that's really long.
That's how you get out. No problem.
Where's the long problem?
I'm getting ready to give you a problem.
Are we gonna have this at 80
And
You'll see
you
the way
want
out
to turn that off in the video. And